hard to believe that GKE and Kubernetes is entering its second decade. It's actually almost a teenager, and for those of you with kids, that's slightly terrifying. The amount of innovation that we've had in the last 10 years is incredible, but what's occurred in the last 18 is even more impressive. I'm Bradstock, head of product for compute orchestration, as well as Kubernetes at Google. Joining me today is Dhoot, who's the SVP of the runtime platform at Salesforce, as well as Gari, Singh, group product manager, and my partner in crime and fellow jokester for the past couple of years here. So we're looking forward to chatting with all of you. Now, before we talk about the future, we need to talk about the past. At its heart, Kubernetes is all about the OSS community. And in fact, we almost have broken the 100,000 contributor milestone, which is huge. On top of that, over 8,000 customers contribute to Kubernetes. Now, many people may think that it's all just hyperscalers like Google doing all the work, but frankly, that isn't even remotely true. A great example is actually Salesforce itself. They've made over 30,000 contributions to the CNCF and over 4,500 to Kubernetes alone, showing the investment and the dedication, the give back they are putting in the Kubernetes community. Now, if you look back at where Kubernetes came from, at its beginning, it was truly a stateless, high-volume, ephemeral system. Now, like Charmander in Pokemon Go, one of GKE's OG original scaling workloads, which still gives some of us some PTSD with the problems we ran into at the very beginning, this has really evolved. We went from stateless to stateful, which brought new challenges, new engineering excellence, and a lot of day two problems. So quick show of hands, because it's middle of the day and let's get some interactivity. How many are running stateful workloads on Kubernetes? Keep the hands up. I'm not going to make you stand up. How many of you love day two operations and upgrades on stateful? That gentleman kept it up for too long, so I will not play him at poker. So there you go. But from the initial work with stateful, we moved into HPC. And HPC was much higher volume and a lot more focus on cost control. And from there, we further evolved. I will not beat the Pokemon jokes to death, don't worry. But we did evolve into training, which brought a lot of new problems because the scale was truly massive. As well, GPUs and TPUs are not inexpensive, to say it mildly. Now, on the training side, AI has caused another evolution of Kubernetes. If you look at training, it forces us to look not just at scaling, but a very different way of controlling costs and measuring success through goodput, because it really was the efficiency you could get from all those GPUs and TPUs. From there, we moved into the fun times that is inference. Inference was stateless, but it really wasn't. It brought a hyper focus on cost control, an even bigger focus on latency, because that was the differentiator between you and your competition, and a new behavior for round robining on the network side, which we'll talk about. And lastly, reinforcement learning took both and smushed it together in a hybrid, so you had to literally get both working at the same time, but the number of capabilities unlocked is unheard of. Agentic brings this all full circle. If we go back, and I keep on saying this internally, my Eng team doesn't believe me, it's really just stateless. But it's stateless 2.0, because the sheer volume of agentic transactions going on right now, and once again, that hyper focus on being incredibly low latent, allows you to take advantage of all the skills and the platform you built for Kubernetes, but it's leveling it up. So you can't just take it and move it, but what you've built into it can be the foundation for that work. On top of it, just to make things interesting, agentic often requires state. Just enough to make it fun and make day two a nightmare, and that's why we'll talk about upgrades a little bit later, but it does change the game in terms of how you view it, especially on the degree of volatility and the needs of this micro-stateful view of an application. And it really does all come together, but at its heart, it's just a new way of using the Kubernetes platform. Now for us, we truly believe in giving back, similar to Salesforce. Google continues to contribute more than 50% of all the contribution in Kubernetes. And in fact, in this past year, we're 15 times larger than the next nearest hyperscaler and 6,000 times more than the next nearest neocloud. The reason I bring it up, other than the very pretty hockey stick chart here, is the fact that actually investing in improving the platform for AI and agentic in particular means that we're able to respond quicker. We've already screwed up on our end, and we've adapted while others are just running on the platform after the fact. One of the coolest things we've worked on, and one that I'm most proud of in the many years I've been working on Kubernetes, is the growth in scaling. If you look at this chart, and yes, I did not draw it, it's definitely Gemini. You'll probably be sick of all the Gemini-generated charts over the course of Next, but this one shows that progress from 100 to 1,000 to 5,000 to 15 to 130,000 nodes. But the big marketing numbers aside, what really matters is the bottom. This is all the problems and challenges we ran into and had to correct both in OSS and within GKE optimize our own hardware such that you don't have to. And I think that's the biggest thing. And I do have to give a shout out to Maciek, who did hours of prompts to make this possible. So you can make charts like this, but it's going to involve a lot of fine tuning, which is the nature of AI. I think more important than the big numbers, though, is the North Star we have this year, building a lot of the tech we launched last year and announcing this week. This is our goal to allow you to scale to 5,000 nodes in 5 minutes with only 5 minutes of effort from yourselves. And why this matters is it then becomes a seamless process to handle any bursty workload, be it trading, be it stateless, be it stateful. We're really looking at that full offering to reduce the complexity for you. On the flip side, though, is that large scale. And for us, getting to 130,000 nodes is a big switch, because eventually a number of the core Kubernetes concepts break down. But we did this in partnership with a number of large model producers because they were pushing GKE to that limit. They would come to us and say, oh yeah, we're going to scale to 45,000 nodes next week. We're like, that's great. And apologies if any of you were in that conversation, and I'm repeating it. But then our Eng team and product team were like, well, how do we actually achieve this? And the way we did it was actually to change the control plane. We moved from etcd, which is the heart of Kubernetes, over to Spanner, which we call Kspan internally, such that we could have greater regional capabilities and virtually, or at least 130,000 node scale. And we did this all in a Kubernetes conformant manner, such that your work is the exact same, and even if you're using other versions of Kubernetes, nothing breaks, which is critical. You do not want to be on a fork that isolates to any one particular cloud. On top of that, we looked at the new challenges of AI, as well as the fact that many of you are multi-cloud. And I don't mean just, hey, I've got one workload in one cloud, I've got another workload in another cloud. It's truly the capability to run your workloads from one cluster across multiple sources of compute. And what this allows you to do with GKE Hypercluster is actually, from a parent runner point of view, push your nodes out to other sources of compute. This could be an unnamed other cloud that makes me sad if you did it, but the capability is there, or even if you're looking at GC compute capabilities. The reason we did this was to push the obtainability of compute on both standard and AI infra, as well as the scale factor to run any workload you could possibly throw at it. There's a session later this week with Glenn Messenger and Anthropic. Highly encourage you to check it out. Bringing this all together, though, is AI Hypercomputer. This is our efforts to not just have Kubernetes, but make sure the hardware, the storage, the network, the layers, the frameworks like Slurm and Ray, Cluster Director, are all integrated in one package such you get an optimized high-performance system on day one. But the biggest difference is it's not lock-in. It's a base layer to make sure everything works to the best of Google's abilities and constantly improved upon, but it gives you the ability to change and select the pieces that work for you. Because inherently having choice with Kubernetes, it's critical to give you the flexibility to put your apps wherever you want them. With that, it's my pleasure to welcome to the stage Anu, who will talk about Salesforce's experience with Kubernetes. Anu, thank you very much.
Thank you, Drew.
There you go.
Thank you, Drew. So it's funny, like my journey at Salesforce also started when Kubernetes started. So I literally joined a month before the first KubeCon. How many in this room were in San Francisco for the first KubeCon? It was not a room unlike this. It's crazy how much the community has grown from there. Like, just imagine how much it's exploded. And since we have been doing Kubernetes the hard way for so many years, we really appreciate when Google does the heavy lifting in public cloud while remaining open source compliant. And so I'm going to take the next 10 minutes, explain our journey with Kubernetes, and show you how we partner with GKE, how it benefits us. So let me introduce Salesforce. As you know, Salesforce is the world's #1 CRM, designed around the customer 360. We're going to make sure your interaction with your customer is a single source of truth, whether it's sales, service, marketing, commerce, or industries. And all of this is possible because we have a unified platform. And what's the foundation of that platform? That's Hyperforce. So Hyperforce is a reimagination of our infrastructure on top of public cloud in a way that hides across substrate the differences, like Drew was saying. It's not just running some workloads here. We run pretty much everything on multiple clouds. That's a hard challenge for us. And to achieve that, we have designed Hyperforce with a certain set of principles in mind. So Hyperforce gives our customers the option of residency within specific geos. They get agility, they get scalability, privacy, all of these features, and using architectural best principles that you might all relate to. And Kubernetes helps us achieve some of this, for example, immutable deployments, elastic compute. As Drew also mentioned, we also have used a lot of other open source and contributed to Istio and Envoy. We have built our own service mesh that lets you go across clusters and gives you zero trust, as well as resiliency when applications talk to each other. So let me show you a little bit deeper into our tech stack. You can see it's like a pie chart. Really, I chart of so many logos, but it's probably a small fraction of the CNCF landscape that you see. So let me start bottom up. On the bottom, we have to abstract all the public cloud vendors, as well as our own self-managed Kubernetes cluster. On top of that, there's a bunch of standard capabilities that you need to layer on to make your cluster functional. So auto-scaling, networking, storage, load balancing, all of these we have to manage, as well as a bunch of custom integrations on top that are Salesforce proprietary, whether it's secrets, logging, monitoring, all of those things. At the end of the day, what's our goal? Our goal is to abstract everything about Kubernetes. So if you want to use Kubernetes, you don't need to manage Kubernetes. So our partner service engineering teams inside Salesforce, they don't have to worry about all of this. And given the complexity, we really appreciate when GKE takes so much of the heavy lifting of the add-ons, so we don't have to manage it ourselves. Also, the way we achieve it, we build a bunch of abstractions and paved paths. Once you're on that paved path, you don't have to worry about these things. And the way we do it using multi-tenancy, using namespaces. So multiple teams inside the company can share a cluster if they want to. If they want segregation, we can put them in different node pools or different clusters. What is the other dimensions of challenges apart from the number of layers of the stack? It's our scale. As Drew was saying, like, the scale keeps growing, and we expect us to grow from thousands of clusters right now to 5x in the near short term. To keep up with this kind of scale, as well as supporting hundreds of service teams across the company, we really need a bunch of primitives. So some of the things we'd love to have GKE support us that we're partnering with is how do you do upgrades? Once you do an upgrade, there are challenges we have hit personally where we hit a corner case nobody expected at the last stage of the stagger, and then you're screwed unless you have a way to roll back. Also, when Kubernetes is managed by GKE, they'll push us updates. We want a way to match that stagger to our staggering. So it needs to go from our dev, test, stage to prod the same way we would roll out our changes. As well as when we scale our clusters, how do you do IP management? Or if you have building a node pool abstraction, there's always a separation of concern between the service team that wants to deploy their apps versus the platform team that needs to give you the primitives. For example, a service team says, I don't care, just put me on the latest and greatest machine generation. I'll keep moving me forward. Or another team like, no, I need to benchmark the perf every time you make a change. So lots of different interesting possibilities. Finally, to wrap it up, I just give you a quick glimpse of what we do, but there are lots of talks we have given at KubeCon over the years. We have a blog, and as Drew said, we are contributing also to open source heavily. What about the future? So there are 3 different directions we imagine the future. Obviously, we need to support agentic workloads, and we need to adapt to different types of profiles, communication patterns, scale. Also, we want to move past single clusters. We want to be able to run apps across multiple clusters, especially Drew be able to do stateful apps easily, do the data ops. As well as we want to use AI to scale our operations and improve our cost efficiency. With that, I'll hand it off to Gari.
Awesome. Great, thanks, Anu. So I'm going to talk about some cool, I call them cool features. So this is kind of Gary's list of things I think you all should know. You'll probably see that I'm excited about things like compute and networking, so hopefully you all are as well. We've come up the last couple years, we came up with this mission. Drew kind of alluded to it, right? But we really wanted to live on the promise of Kubernetes, right? You move to cloud, elastic scale, fast scaling, right? But then you're like, it took a minute to scale my node, to get my pod scheduled, blah, blah, blah. You end up sort of over-provisioned. So how can we move that to actually a more near real-time or real-time kind of scalability? We mentioned this last year. It's still our mission. But the great thing is we actually delivered. Some of you may have seen a demo last year where we were kind of in the earlier stuff. We recently introduced super fast scheduling. So we have a container-optimized compute. It is part of Autopilot when we launched it last year. But what you'll see is like almost 7x faster scaling, right? We use a little bit of magic. We resize some VMs underneath the covers, but super fast. On the GPU side, how many folks here do run GPUs today? A few folks. It can take 2-3 minutes sometimes to actually start these nodes up. They do a lot of registrations, GNI, exactly. We're now up to like 2x faster scheduling on those nodes. And you'll see that today for like the L4s, L2s, L4s, G2s, G4s. As well as like A100s, A100s, and other compute. So check this out, super fast computing. The other thing, how many folks have, I'll just ask the question before I tell you what it is, how many folks have heard of compute classes? This is good, this is good. Now I'm going to do this, I know it's being recorded, but we should do it for evidence. How many folks have heard of Carpenter? Boo. But the good news is more folks heard of compute classes, so this is good, we're making victory. So on the compute class side, one of the big things, how many people today just configure their own node pools, configure nodes? Like, I got to find the right sizing, right? Yeah. Everybody ever run out of compute or found the wrong node type? Yeah. So we aim to kind of like solve a number of these problems, what we call compute classes. And this is probably, think of it as a new way to configure the underlying compute for GKE. No more sort of don't statically configure node pools. So as you can kind of see from up here, the way this works is you can specify the order and priorities of compute you want to use. The most common, let's say the cheap case is I want to use Spot, right? But then we don't always have Spot, or Spot may get interrupted. So then I may want to use N2 Spot or whatever I have in here, N4 Spot, then I'll take C4 Spot. If not, I still want my workloads to run, so let me fall back, right? So let me use standard. But the nice thing is you'll see there's a thing called, we don't name things the best, but we have optimized rule priority. Where is it? Migration somewhere in there. We'll actually move workloads if that compute becomes available, right? So you got put on a standard on-demand node. Now Spot becomes available. We'll spin that up and move that. So definitely compute classes are kind of the way to go. Cost efficient. They also handle things like if you ran out of like whatever N2Ds and you can go to N4Ds. So compute classes are definitely the way to go. Now this is kind of an interesting use case. This is from one of our, Drew mentioned we want to get to like 5,000 nodes in 5 minutes. Interesting fun fact, we used to think that like 100 node clusters were big. We have these huge clusters, but not everybody had them. Then we thought 1,000 node clusters were big. Then we started looking around. We actually had a lot of people with 5,000 node clusters and people with 8,000 node clusters. And now we start to see these workloads where people want to run big batch jobs or just scale, and they want to get to 5,000 nodes in whatever amount of time it takes to run their job, and then scale it down. Some of those issues are maybe we didn't have availability of specific compute type. So you can kind of see here that we're able to actually hit all these spikes, and the different colors actually show the different priorities, right? So instead of waiting for capacity to be available, if it wasn't available on whatever machine type you wanted, we can fall back to another and meet that elastic demand and quickly scale up and down to those multiple nodes. And this is becoming more and more common. It also works well at small scale as well, too, right? Maybe you don't have enough quota for a specific thing, so it also handles that. Another kind of cool feature that we introduced for AI, but I'll put it in here. How many people, I don't want to insult my old friend Java, but how many people run things like Java workloads? And then how long does it take to start Java workloads? A while, right? There's techniques to do some of them, but some of them take a while to start. What's that? Oh, yeah. So if you use Quark or some of the old ones, yeah. Or if you're using AI workloads, right? Even things like VLLM take a while to start. So the idea with pod snapshots here is let's get the pod up to the ready state, right? So now it's ready to serve workloads. We'll take a snapshot of that. And now, for the next instance of that, or for a future instance, we can actually use that snapshot to start the pod. So no need to download the container image, no need to start it up, no startup time. It's literally the state snapshot of that. And this achieves, like, again, super fast scaling of those things. So you start to see the direction, right? Scale up, super fast compute scaling, super fast pod scaling. Now, another feature, how many people here have using GKE Autopilot today? Oh, this is pretty good. So a good crowd. Now, we used to hear, we had a lot of people, Autopilot came out later. So people were already on standard, and they're like, I don't want to create a new cluster, or maybe I sometimes have to run some things on standard. So last year, I think up on stage, we announced that we were doing it, but we actually did do it. At the end of last year, we now have a unified cluster, right? So we still have Autopilot clusters, but any GKE standard cluster, you can now run Autopilot workloads. So all that high optimized compute that I talked about, on any cluster you have today, I think 133, 134 or later, to be fair, you can now try these Autopilot workloads on that. So the goal here is reduce friction, right? Don't have to make a choice up front, no 0 day, like, do I want Autopilot, do I want standard? You can literally start with one cluster, and then you can move one way or the other. So this is the new GKE. We made that available last year. And we're seeing a lot of uptake now with the ability to use the built-in Autopilot compute classes. This is one of my favorites. I don't know if everyone else will get excited. I hope you do. Does anybody today use horizontal pod auto scaling today? Do people use custom, try to scale off of custom metrics for it today? Yeah. How many people love configuring custom metrics with the fun adapter and then coming up with a metric name and yada yada? So finally, we solved this problem. So what we actually did for what we named it native support for custom metrics. So what we're doing now is any pod today, it's Prometheus metrics. We will support also OTel later. If your pod is exporting Prometheus metrics, we now have a built-in little GKE collector that can scrape these pods. You configure it with a CRD. You'll see on the next slide. It automatically starts scraping those, and then we send it to a super fast little aggregator that we have. So it's not going to manage Prometheus or the metrics. It's strictly going to someplace for auto scaling. This is allowing, one, you're going to know the name, so deterministic, but also we've reduced the whole speed cycle, right? So now we're doing this in real time and real-time processing the metric. And what does this look like from a configuration perspective? I didn't show it, but essentially what you end up having is this thing called an auto-scaling metric CRD. You name the metric, say what you want to scrape. That metric name, you put in your HPA, so you have that ahead of time, and you're off and running. No adapter needed, nothing needed. And because we've also reduced the HPA, now a 5-second loop, you literally can actually start scaling in real time. So I was playing around some weekend. I was bored. And I was like, let me try this out. Let me see if all this stuff that I'm telling the audience about, does it actually work? So, and then how do I kind of show it? Hopefully, where's my video did not play. Do you have the video back there? Okay, there we go. They have the back. So the idea of this video was pretty simple. I have an HPA, and I've decided to scale on basically, you can see the metric here was requests in flight. Right? So I decided that pods could only handle a certain number of requests in flight. What you'll see is we're seeing real-time update of the HPA. If you played with this like before on earlier versions of GKE, this would take like 1 minute, 30 seconds, whatever, before you might even see the update. Then it might take you another minute, 2 minutes, a minute and a half before you'd see the pod scaling or the node scaling. If you look at the velocity here, as the number of requests are coming up and the in-flights are going in, we literally are handling that scale and that pressure in almost near real time. And you can see it's a natural kind of step function, the way that things are kind of working. So, and again, this took me 0 time to configure. I went in, said, use our new super speed compute, annotated my pod, created my auto scaling metric, deployed it, and in 5 seconds. And then, of course, I used Gemini to build this application because I can't code graphs that look like this. I literally said, build me a cool graphing application that shows fast pod scaling for my presentation at Next. And that's what it came up with. So, now, what else are we doing? Trying to make GKE easier to use. We had Autopilot, but we want to make it even easier than that. So real quick, I won't go through all these questions, but how many people today you want to solve a problem on GKE, maybe hopefully you go to an AI tool, but did you remember like searching Stack Overflow, searching Google for something, right? Or you're like, here's my YAML, why didn't it work? Is something valid? Or something was wrong with networking, and you're like, hey, can I find the networking person who configured this? And until they do that, we're on hold, right? So it's kind of all these things that are involved in operational kind of tedium. So the real idea here is like, instead of looking for things, you want to go towards more this like, AI sort of driven approach, start looking, right? And not rely on documentation. We know most people, does anybody still read documentation? Or do you just ask your AI assistant, how do you do blah, blah, blah? And and one of the ideas isn't necessarily to do.
How many of you use Claude Code now for all your systems? Okay, that's good.
So, more from that and how to. So we'll move sort of quickly. So even though I work for Google, nobody told me that we had this thing called like Gemini. So I went and was looking for, again, this is not my videos. There we go. So I went and built this sort of thing using AI. So I'll show you the magic steps on this, but, I don't know why it's not. No, wait, anyway. There it is. So we'll show you how this was built, but I essentially went to Claude AI, the web-based thing, and my goal here was, can I use some of our new AI capabilities, MCP, et cetera, to basically just build and deploy a best practices cluster in an application? Meaning I don't have kubectl installed anywhere because this is on the web. I don't have gcloud, and I'm literally just using our remote MCP server, which you might have heard about from this morning's keynote that was announced. And I was like, well, we'll use Claude because maybe you don't believe if I use Google demos that we just hard coded something. I fast forwarded this a bit, but it was super fast. And you can see, like literally, I could do this on my phone. This is scary because I have full access, but on my phone, right now I could just provision a cluster that Drew will pay for. And it works out great. But in all seriousness, right, if you look at my prompt, it was, I want a best practices cluster for development, right? And it came up and figured out to do an Autopilot cluster. It's reading our best practices, and we were able to do that. And then magically, it was also able to deploy an actual pod, right? And again, that's all from a web application, no tools sort of deployed. So how did we do that? We just released, I think you may have heard of this, we just released our remote MCP server. The nice thing about it, if you played with it before, has anybody heard of it or played with it? We're getting there. Let's hopefully, tomorrow, I'm going to ask the same question to all of you, and we should have more people using it. But we had a bunch of read-only operations, but now we also have write operations as well. So you can actually create clusters, you can actually patch deployments, do deployments, et cetera. Don't worry, you can actually set a rule at an organization level that maybe people like Drew should only be allowed to use read-only for the MCP tools and not write-only, and Gary can have write-only access. So we've done that, and we're continuing to invest in that. But this is really nice because now you can plug this into your assistants, your tools, your agents, right, again, without having to have gcloud, kubectl, or even understanding those commands. Also, I should have gone to the keynote this morning, but I'm pretty sure that this is either being announced today or tomorrow. How many people have heard of skills? MCP skills, right? So we're actually also releasing, or Google Cloud is in general, releasing a bunch of Google skills. You can go to github.com/Google/skills. We have Kubernetes in there. And again, this was kind of a whole process of how do we configure best practices clusters? How do we do everything from things like workload identity, security, managing all of that, taking you through that path. You can plug this in and work again with any of your AI assistants. So we continue to work in that. As for the record, the golden cluster is Gary's cluster, because I built this skill, but I figured that was the best practices, but it does work super well. So again, we're really trying to get into that agentic operation spirit, right, of how we can do this. And then, as I mentioned, I jokingly said, I of course know that we have Gemini and other products. I won't get ahead. If you do go to the developer keynote tomorrow, you'll see a revamped version of Google Cloud Assist. And some of the tools that I showed you, we now actually have the ability to deploy, like Kubernetes deployments, actually and generate YAMLs through Google Cloud Assist, do Kubernetes deployments on that, and not just do infrastructure deployments. And you'll actually see some additional troubleshooting. And this is just another manifestation of us eating our own dog food, because we're actually using, GCA uses our own internal MCP to do this. So check that out tomorrow, or watch the video. And then one other cool one, because my boss man Drew, we also work closely with our compute folks, a very cool, another AI feature is called Compute Advisor. So check this out. We have a lot of machine types. And how many people know exactly when you should use which machine type? Does everybody know? Here, you can literally go in here and say, here's the type of workload that I want to run with the best price performance, blah, blah, blah. And it will give you what your compute shape should be, what size you should be, what pick on all your options. So this is actually built in as well. This one just launched as well for kind of raw compute. All right, how am I doing on time? Good. All right, I'm going to pass this over. We asked this, how many people really do like upgrades besides from me? I love upgrades, but
That's all I can say. No one loves upgrades.
But I'm gonna pass this on to Drew to talk to you a little about what we're doing with upgrades.
First of all, I think my credit card or my zero broke thanks to Gary, so I'm hoping that skills doesn't actually tie into Gary's cluster. But all joking aside about upgrades, it has become another tradition for Gary and I. How many people are using release channels? Show of hands. Okay, how many people were not using them a year ago but are using them now? Okay, so I like you. You're one of the lone hands, so thank you, gentlemen in the blue. But what we've been trying to do is give you more flexibility for upgrades. It's greater control and automation. And the way we've done this, if you look at rollout sequencing, this is one of the best things we've launched in ages because it allows the upgrades to reflect how your business actually works, right? Because no one, unless you're really YOLOing it, you don't do one mass upgrade on everything. That is literally a disaster waiting to happen. Set rollout sequencing allows you to set gates as you go on certain indicators that then allow the next phase of the upgrades to occur. So you don't have to string this together with cats, string, and bash jobs. Now, what we added to it, though, is the ability to do this within chunks as well. So within, say, dev, test, prod, you can start having additional gating as you go through this to truly reflect the risk and the mitigations you want to have in place as you go through it. So if you're not using this for upgrades, I really recommend you do, because it gives you control. Unless you've got one cluster, and then you're far braver than I if your entire business is one cluster. But this gives you that control you need to make sure it's safe, and you're catching things as you go. Now, second, and big shout out to Jago McLeod, who's one of the OG people in GKE as well as the Kubernetes community, was the ability to do minor upgrades with rollbacks safely. Because this has been a huge problem. You think it's minor. For any of you, like even running Salesforce, I'm sure you can do minor version rollbacks, and if I can't, I'll eat it later. But within Kubernetes, this is something that didn't work well. Instead, what we've got now is the ability to go forward, safely check it's OK, and give you the ability to roll back on this. And there's a lot of good details in the documentation and on the skills side. But I highly recommend taking a look at this, because it's like a safety valve for that minor version, which can be really handy, especially with the volume of API changes we have across Kubernetes, because we're constantly moving the platform forward. So check it out. I think this additional level of control and a safety measure will help a lot. Now, to complement this is the ability to give you greater control, once again, on how things are being disrupted or how you want to protect against key business cycles. Salesforce, for instance, has to deal with a lot of peak areas for their customers. It's not just BFCM. It's going to be global in terms of what's happening, and they have to plan for all this, which means they have very strict controls on how they upgrade the Kubernetes clusters in many, many ways. One of the wrinkles we're trying to deal with now is the fact that compute is tight, right? That is just a fact in the market. It could be your compute, it could be a cloud compute, it could be on-prem, but having greater control over disruption budgets such that you're not stuck when you can't actually upgrade depending on how you do it, we've added additional functionality for that, as well as a lot of new options in terms of how you want to have exception windows or blackout periods, such you can tailor GKE automatic Kubernetes, the upgrades, to exactly how you want it, as well as be able to decide if it's purely on your end or automated by GKE. Flip side of this, because at its heart, if you don't have storage, you're not really going anywhere with the Kubernetes cluster. We really listened on one key problem that we had within Google. Because as we moved the series of the different VMs from 1 to 2 to 4, there was a difference in terms of how really storage was handled. And this created a disconnect, especially for those of you using custom compute classes, which is amazing to flow through, but people found the way they did storage, say, on N2s versus the N4s, ran into a big disconnect and it wasn't smooth. So that magic chart that Gary's over there that he put together would make Gary a liar because we ran headlong into a problem where the wrenching storage differences didn't allow that fluidity and didn't allow what we're coining as fluid compute, so we had to change it. So what we actually did was we've created a single storage class across all these different VM families to allow really to hide the differences here such that you can flow between different VM families. This may seem like a minor detail, but in terms of avoiding a lot of the problems we've seen some customers have, this is a huge step forward because it still allows you to customize as you want, but from a scaling and VM flexibility, it completely hides it. On a similar note is the work we've done with Managed Lustre. I'm curious, how many of you are running Managed Lustre right now? OK, thank you. I like the guy in the orange too. So I like all of you, but there's certain people tech-wise I like more. But Managed Lustre for us has been fabulous. If we look at the massive needs of storage, especially for AI training, being able to tap into this and just the sheer throughput it can go through has been great. The issue, though, is configuring any highly performant system, the more knobs all of you ask for, and trust me, Anu has asked for a lot of different knobs from Salesforce, it's great, but it adds to complexity. So what we've done is highly tune Managed Lustre to make sure it works well right out of the gate and is optimized for these large training workloads in partnership with our fabulous storage engineering team. With that, I'm going to turn it over to everyone's least favorite subject, networking. There you go, Gary.
All right. Thanks, Drew. All right, we're going to run through these kind of quickly. We have to be fair and cover networking. I know it's a little esoteric for some folks, but the TLDR of this busy chart. We now have the ability, finally, in GKE, you can add and remove multiple ranges for pods and node pools. You can do this for services as well. And finally, you can do this for node pools, the primary CIDR. You can now actually add multiple nodes. So most people, the big problem, TLDR, you've misconfigured your range. And then you can't scale your nodes, right? Because if you put a /20, /28, you get 256 nodes. And that's it, unless you could add, increase that particular range. Now we have the ability to add multiple of those. And you can then also, if you really messed up, you can add a new one and get rid of the old one now. But what does that allow us to do also under the covers? Let's say you have the luxury of creating new clusters, because it's so easy with AI to create new clusters now, you can turn on auto IPAM. And in auto IPAM, because we can now dynamically add and remove all these subnets, we can start off super small for your clusters, give you smaller ranges for these, and then increase them on the fly as needed. So all these features are available, made networking much easier. I'm sure the people who started on this 10 years ago would have loved to have had this back then. So then just a couple things on what's next. We're at next. So what's next? So this truly was a Gemini-generated picture, but I just thought it was freaking awesome. Sorry. Just had some multiple colors. But our real goal is, I think we want to get to autonomous operations, right? And we have so many of the building blocks now. Some of these, automatic IPAM. We've got this fast scaling compute. We've got monitoring. We can really get to the point where, one, we can make it easy, obviously from the outside, but now we can monitor your workloads, right? We can technically figure out what your workloads are, even make recommendations on the fly, and then enact those recommendations. We could right-size workloads in place. And then clearly the big use case here is really kind of SRE or troubleshooting. But being able to have all that information and integrating with sort of GCA. So you're going to see that over the course of the next year. But if people are interested in this stuff, start with our MCP stuff, start with GCA, and reach out for sure, because this is a big area for us. And actually, you can look on your calendar. There's a workshop on Friday where we'll go, if anybody's interested in contributing going forward. This is a cool feature. Long story short, many people want to do things with compute with ratios. We talked about fallback. But a lot of people, you might want to say, I want 50% spot and 50% on demand. You can't actually do this with auto scaling sort of today. So that's what this ratio will do. This should be coming out in short term. This is probably one of the most asked for compute class features. It will also work for any type of compute. So if you wanted like 50% N4 and 50% M4D, or 50% ARM and 50% x86, it'll work for any of those. Look for that coming shortly. Should be here like before the first half, hopefully, but don't make any purchasing decisions based on that. The other cool feature that we did, so I talked about fast scaling nodes, but those were limited to specific, more the generic compute. The other thing that we have, we implemented an API in open source called the Capacity Buffers API. So the idea here was that if you use the cluster autoscaler today, the cluster autoscaler is always only going to add, right? You can't actually tell the autoscaler to always have 2 extra nodes available. So people do this with balloon pods or lower priority things, but we actually introduced this thing called capacity buffers, such that you can say, always have an extra node, right? Or always have an extra 10% of nodes as I sort of dynamically scale. And what we've done on the GKE side is we have two versions. One is you can do active, which means you're paying for the node, but you're still getting that compute running hot. But we now also have standby buffers. This feature just went into preview. Check it out. It is slick, super slick. You turn on, it basically is using suspended VMs, but you will now see for any compute type how fast these nodes actually scale and respond. And you combine that together with like the metrics and other stuff that I showed, we are like on that path of truly hitting that almost near real time. And then one last thing that we've been working on, we talked about last year a little bit about this. How many people were familiar with the in-place pod resizing feature? Basically the ability to change the requests and limits of a pod without actually restarting it. So we worked on that. That's out there now. We've been working on the VPA, Virtual Pod Autoscaler, to do that. That's in sort of preview, in sort of open source. And then we're adding another feature, which we call CPU Boost. I did talk about this last year, but we are doing it now. CPU Boost, the idea is give your pod more CPU on startup, and then automatically downsize it once it hits ready, right? So you can start to, and you can see you can start to combine some of these features with doing that. You could like scale it up with 5 CPUs, scale down to 2, then even take a pod snapshot, right? And now you have your thing optimized, started, and running. So that's CPU Boost. So all these features, as I said, we're starting to come together with workload-focused auto-scaling. It is, as I like to say, it is pretty slick, and it all does work. And then lastly, we're back with this feature. Those of you who have been on our campaign for like the last 5 or 6 years, we had looked at predictive HPA a while back, but we had some issues. But now we have some better ideas. The idea of predictive HPA, now we're pretty good at being near real time, as I said. But how many people, you have like workloads that happen at the end of the week, big batch stuff, patterns, traffic patterns that people can pick up. It's when Asia comes online, we have a big one, when the EU comes online, and when the US comes online. There's all kinds of patterns. So the idea of predictive HPA for us is to watch those patterns of data, right? And then instead of you having to necessarily configure, auto scale at 10 a.m. because I know that all my whatever is coming online, we'll find that pattern after a certain amount of days of data, and we'll automatically have those nodes and pods up and running for you before an auto-scaling event actually occurred. So look for predictive HPA. This should be going into a private preview pretty soon. Reach out if you have any questions. Of course, because no one should ever allow Gary to make charts, if you have any questions or concerns, this email is real, by the way. Try it out. It goes to askdrew@google.com. We both see it, so I will correct Drew's answers. Yeah. But no, in all seriousness, Drew and I love speaking with customers. If we really do, if you do want to have a chance, we probably won't have questions because I talk too much. Feel free to literally ping us on this address. We will respond, happy to meet with you, talk to you about anything. I put together, so we covered pretty fast, hopefully, a bunch of topics. If you want to hit this QR code, I think it should work. I'm not allowed to log into my own playlist, but this is basically some deeper dive sessions covering a lot of the stuff that we did today. So there's a deeper dive on auto scaling, some more stuff on compute classes, some use on massive scaling, et cetera. So all those sessions are in that list. And I guess I'll leave it with, you've probably heard this at other sessions. Your feedback is greatly appreciated. So Drew and I can come back and do this again next year. Hopefully everyone liked that. We'll bring a new as well. And I don't know if you guys want to stand up, but with that, thank you so much. I really appreciate it. It's always great to see so many people here, and thanks for using GKE.